Hello again, and in this video we're going to be finding we're going to be using antiderivatives using the power rule. Now this is just going to be a quick little video to show you just what to do, or at least how I do it, and I think it should be very helpful and relevant because it's going to be very important later on when we get into not improper, when we get into just integrals in general, in general, for all types of integrals. Alright, so the power rule here states that it's basically the opposite of the derivative power rule. When you take the antiderivative of something, it's actually whatever you take the antiderivative of, when you take to check your answer, you can take the derivative of that, and it should take you back to your original answer. So I can show you real quick. What I usually do is I usually add the exponent first. So this will actually be equal to x to the fourth, but then we still have to add the 1 over n plus 1. So this is actually going to be times 1/4, because this is actually 3, this is actually, the n is actually equal to 3, so the n, this one's equal to 3. So it would be 3 plus 1, which would be 4, and then you do 1 over the 4. The 1's always there, so it's just 1 over the 4, which would be, this is actually then equal to x to the fourth all over 4. And this is the antiderivative of x to the third. Because now, when we take the derivative of this using the power rule, this is actually equal to 4x to the third all over 4. And look at that, the 4's cancel, and we're back to x to the third. So when you can take the antiderivative, and then the derivative of the antiderivative is equal to the derivative, if that makes sense to you. I'll show you the next example. Down here, we have x to the third, so I add the 4. So we're going to be multiplying 1 over 4 times 3 over 2 x to the fourth. So this is actually equal to 3 all over 8 times x to the fourth. Now, when we take the derivative of this, just to check our answer, it should take us back to 3 over 2x to the third. So this is actually going to be 12 all over 8 x to the third. This becomes 6 over 4, 3 over 2. 3 over 2 x to the third. That's our original equation here. So we took the antiderivative, and then the derivative of that antiderivative was equal to the original answer. I mean, it's a bit of a tongue twister, but it makes sense if you say it slowly. And then we're going to do one last problem. This is just supposed to be a quick video to demonstrate the power rule. I mean, these things don't get much more complicated than this. I mean, it's pretty simple. It was 3 over 5x squared. Alright, so we just, remember, add to the exponent. I mean, when you start out, once you get a higher level, you can basically do these in your head, but at a lower level, just to process it, you might want to just write it out. So this would be 1/3 times 3 all over 5x to the third. Because remember, these numbers should always match. Here, the n plus 1s, the n's are always the same for both of those. So this will give us 3 all over 15x to the third. Now when we take the derivative of this, it will give us 9 over 15x squared divided by 3 be 3 all over 5x squared. And there you go. It's the same exact thing as this. So you can take the derivative. Oh, hold on, let me draw the thing. The derivative goes to the antiderivative. But when you take the derivative of an antiderivative, it takes you back to the derivative. So take you back to the derivative. This makes sense when you learn the fundamental theorem of calculus. It's actually antiderivatives and derivatives are the same thing. That's when you're integrating something. It's the same thing as taking the antiderivative of it. So that's just a quick little video using the power rule for antiderivatives, and I hope it was helpful. Thanks.